Good afternoon, everyone. Welcome back. In the previous session, we were looking at the NumPy, which is a numerical Python. So this actually belongs to the fundamentals of Python, which we had started a session before the last session. So a numerical Python, in that particular part, we had seen that how a specific library called as a NumPy or numerical Python is capable of building up and handling the multi-dimensional arrays and how we can use it to manipulate the data, right? So that was a fundamental session related to the numerical Python, all right? So in today's session, we are going one step ahead and we'll be looking at a very specific library called as Pandas. So it is very similar to the NumPy, but it is built up over the NumPy. So if you consider NumPy as a basic, right, on the features of NumPy, right, people have built another library called as Pandas. So Pandas is on a higher side. So since we are aware of the operation and how to use the NumPy, right, we'll be extending the same concepts to the Pandas. So if the Pandas is built up over NumPy, then obviously there will be a question saying that, then what is the difference? So the difference is in NumPy, irrespective of what is the dimension of the data, right? It can be, let's say, a two-dimensional data. In the sense, we try to create, say, matrices. We started from matrices, then we move to the multi-dimensional cases as well, right? But when it comes to the Pandas, it's normally dealing with a two-dimensional data, and each of the data point can be accessed by either a label. In a sense, with respect to every row, you have a label, okay, and with respect to a column also, you have a label. So you don't have to access the data by using some indexing like 0, 0, 0, 1, right? So normally, if you have a matrix A00, A01, A02 along the row, and along the column A00, A10, A20, A30, etc., we had such accessing methods, right? But now, when it comes to the Pandas, you have some flexibility. One, the fundamental idea is that you will have to, it's a must, right? So you have to give a name to every column, and row-wise, even if you don't give a name or label, right, you can assign at least zeroth row, first row, second row, third row, and so on. So that is one very fundamental difference. In addition to that, each column can have different data types. In the sense, one column is completely names, right? So let's assume I have a table of every employee, a table which consists of the details of employees of my company, right? So what will be the row-wise number? Mostly the row-wise, I'm going to give a name like employee ID. So I create employee IDs. So the first column is name. So name of each and every employee of my company will come here. So after that, maybe you will write a date of join. So see, look at every column. Every column is unique. Every column is going to have unique data type. Throughout that column, you are going to maintain the same data type. So in under the name, I'll not write the date of joining or date of birth, etc. Right? So that's the fundamental idea. So this was not possible in case of the NumPy. NumPy had a restriction that everything you write has to be of the same data type, right? Like only float, everything. It may be 2 rows, 3 columns, 10 rows, 20 columns, 3 copies. So multi-dimensional data, right? You consider in any of those scenarios, we had to put the same data type everywhere. That was a restriction. So to overcome, we have to go for Pandas. That's the first idea. So it actually helps you in building up the storage spaces consisting of various data types. That's the first thing which you need to understand, right? Again, if you have a data which is like something like a array, right? In an array, I I store the same data type, right, irrespective of whatever is the length. So that is also supported over here. We are going to call it as a series. So fundamentally, the Pandas has two different data types available. The first data type is called as a series, right? I just have a label for that. After the label, I have, right, various number of entries coming up, all are of the same type. In a sense, if you have a table, one particular column we are talking about. A column has same data type. On a table, if you consider only one particular column, that is what we are going to call it as a Pandas series. So Pandas has one data type called as a series. So it should be, right, you should be able to understand that. Series means it's going to have a series. In the sense, if I say in maths, if I say series, it's a repetition of same numbers, similar numbers like 1, 5, 8, 7 integers, like that. So integers belong to the same data type. Like that, Pandas supports one data type that is called as a series, right? Series can be, you can generate the series of names, series of time, series of date, series of integers, series of floating values, and series of objects. Many things are possible. We are going to look at it soon. So that is what is the first thing you should understand. Okay, so the second data type is called as a complete table. The Pandas calls it as a data frame. So one is series, second one is data frame. Only two types exist, right? But within these two types, right, though it supports only two types of, right, fundamental data types under this, it actually imports everything that is under Python. You can, in Python, whatever you have used, you can use it inside this. So actually there are many options, but basically when I talk, I have to say that Pandas supports two types only. One is a series, one is data frame, right? Data frame is a complete table. Series is one column of any table. Okay, so basically we will be starting from creation of those kinds of data frame. So how to create a data frame, how to create a series, etc. We are going to start from there. Then as the time progresses, you will be able to understand that. We will also look into what are the types of data manipulation. How do you access the data? Once a table is created, say data frame is created, how do you access that? How to access that? That will be seen. Then we'll see the various options to modify, right? How to select certain only few data depending upon some conditions, right? How to slice, etc. Everything you have studied earlier is going to repeat back, but that now we are going to concentrate only on pandas. So when it comes to what, so now I'll tell you about another point, that is why this pandas is very important. It is because most of the time we have to process the data which is available in the tabular form. Okay, you collect the data for your application purpose, right? You want to build a machine learning algorithm, and in such case, I have to collect the data, right? So when you collect the data, it will normally come in the tabular format. So tabular format should refer to, okay, my first instance, second instance, third instance, fourth instance, and so on. So like that, when I collect, I keep on getting the rows. At the same time, you may have different values coming up in columns. Each column is the same data type. So, right, that is obvious. So because of that, we have to have a support, right, which actually is very efficient in handling the tabular format, right? So tabular format, right, is supported by Pandas. So we are studying the Pandas over here. So very important, right? If you study the Pandas very properly, right, I can say that, like, most of your concepts that you are going to learn as a theory under the machine learning concept, implementation wise, it becomes very easy, right? You have to study the theory part. There is no way, right? Because in order to study the theory, what are the various concepts we have to go through from the basics, I already have mentioned, right? So when we discussed about the very first class of the machine learning, you already know, okay, these are the various basics I have to know, so that yes, you can you can get familiar with the concepts that are required for ML, right? When it comes to implementation part, we need the software support, right? One of the very good tool which becomes very handy is Pandas. But I cannot directly jump with Pandas. Pandas is built upon the numerical Python, NumPy. So we studied NumPy before this. NumPy is actually an advanced version of your fundamentals of Python. So we started with the Python at the beginning. Okay, so there is connection. Whatever we are discussing in our sessions, there is a connection. So I actually started from as much basics as possible. Okay, below that we couldn't start, right? We don't have that much time. So because of that, right, this is what we are doing now. Okay, so with that introduction, let's directly jump into what is called as Pandas. All right, so the first thing is how do you install, right? Because Pandas, as you know, it is a completely different tool. It is a library. So it will be already installed, right? Where as soon as you install Python, this Pandas comes along with that. You can actually check that by first importing. Import Pandas. All right, so it may give some error, doesn't matter. Now, there is a warning, not error, sorry. If there is an error, it means you don't have Pandas, but as you can see, there is no error, it's just a warning. Right, then I'll check the Pandas underscore version underscore. So as soon as you enter, you can see that this is the version which I have. Okay, so same thing you can even check if you are working with the Google Colab, right? There also some installed version will be made available to you whenever you run that. Okay, then let's proceed further. Normally we have to import the Pandas. Again, it's always a good habit to use alias. Otherwise, you need to type pandas every time, right? So what we do, import Pandas as PD, right? Again, this is a short form, right? PD is an alias commonly people use. That's why we'll stick to that. Then if you just check PD after that, it actually shows in your system what's the path and which is the environmental variable that you are using, etc. You can get a detail. So if something like this comes, means yes, you have a fully working version of the Pandas available. All right. So then let me tell you how to get the details once again. I write PD dot. As you can see, if I enter the tab, right, it should show the complete list of the functions available right under this case. So if you want to know everything about the Pandas, you can go with each one of them. For example, I'll just write pandas.series, right? And I'll write a question mark after this. So you can see that you get the complete details of that. The help is available, right? So you can use it. So that's it. It actually remains pretty much same for everything. All right. That's one thing. And okay, let me modify this. So if I just write PD question mark, you'll get a complete help of the Pandas itself, right? Again, this is very basic help. So proper help, how to get, I'll tell you now. Okay, so the first thing is Pandas user guide. All right, so just see here, I'll paste it in this so that when you get this material, you can even check that. Okay, so this is one thing, and let me copy this part so that I'll paste it in the chat box right away. You can please check them. All right, so you can see that this is what is called as a user guide. So as soon as you click this, a web page opens. So that actually gives you the complete help in terms of the user guide. So maybe depending upon which version you are using, you may have to select the appropriate version of the user guide from the top of the page which you which you get over there. So let me just show you that as well. I'll just open. So let's see. So this, just a second. Let me check. So you can see that This is how it comes, and on the top you should have an option, right, etc. to available, so that we can change this. Over here you can see that this is the version, right? So right now I'm using 1.3. It's already by default it is 1.3, 1.3, 1.4.3 because it is the latest version, right? If you want an older version, definitely you can use, right? So look at the details over here, right? Everything related to the pandas is available. It may take some time for you to go through each and everything, right? That you can start doing that at a later stage. Just go through our session, what we are going to discuss today. That will be the very important concepts, right? We will not be able to cover each and everything under pandas for sure, because pandas is too huge. So I can make a comment related to pandas that there is nothing in the world which pandas cannot do, right? If something which is there which pandas cannot do means you actually cannot do that at all. So it's something like that. So pandas is up to that level, right? So much of good support is available, right? Whatever you think, okay, I have a data like this, I want to do something like this. Is it possible? If you think something like that, go to this, search something, find it out how to do that, implement that, because each and everything is possible in the pandas. Okay, so right, that's the user guide. Let me go back, and there is what is called as a API reference. Let me give a link for that as well. So this is what we call as a pandas API reference. Another reference which is also very helpful. You can click that and you can check, right, the usage of that. Let me open that. This is called as API reference. Once again, you have related to each and everything, you have a complete detail. So general instructions are there. Then you see the first data type we discussed, it is called as a series. Everything related to series. What are the various things you can do with respect to a series? These are the various things that are there. So out of these points, some of them very important things we are going to discuss today. Others, it's left to you. All right, very similar to that. You already know that there is another data type, that is a data frame. It's a table, right? With respect to the table, what are the various things that you can do? You can see that again, out of them, few of them are we going to see, right? Then some more things are there, right, which we may not be able to touch under our current session, right? But yes, you can definitely, you know where to search if you need some. All right, so this is how we start with. We start with importing NumPy as NP. You know that why we are doing this, because NumPy is the basic one. Then import as PD. Already I have imported the pandas, but let me do this together. So now we are actually starting with our actual concept. So you need to start with the NumPy as well as the pandas. So the first object is called as the Pandas series. So in that means it's called as a series. It's a series of data, right? So let's start with the creation of a Pandas series. So let me start with that. My data is equal to, see the method, this is pd dot series. So pandas dot series. You have to enter inside the normal parenthesis. You have to open up a square bracket so that you can enter it such as a list for this. Okay, so I'll just write 1.2, then 5.9999 and minus 100, then 2000, etc. Let's see. Okay, so that is my data. So let's just look at this. So what happened? I told series is only one column of your table. So this looks like a table for you, right? Each tables, every element has a index. So 0th value is 1. First value is 1.2. Second value 5.99. Third minus 100. Fourth 2000. So observe one thing. It's like a simple array, but you have labels associated with each of the value that you enter. That's the first thing which you need to understand. So very simple like an array, but array's index was not visible whenever we created an array in case of normal NumPy, right? In a NumPy array, the array index was not visible, but here it is always visible. You can see that, right? That's what is happening over here. Okay, so just verify that once. So I suggest you also work with me. I'll give enough time so that you can also type and you can see. This is what is highly suggested because you get adjusted to the various terms, typing, etc. Okay, so please do that along with me. We'll go slowly, we'll understand everything and we'll go with the normal case. Right. So this is the case and let's try to check whether I can see what are the various information that we can get from this, right? In order to understand what are the various attributes of this. So let me start with the name, the my data dot, I'll write values. In the sense, if you have been given a series and you don't know the various properties of that, you can definitely check that. How to check that? So write the name of that variable dot values. So as soon as write that and you enter, you'll see that all the values will be printed. Other details are not. Similarly, sorry, it's my data dot index. So you can see, right? It starts at 0, it stops at 5. In a sense, it will not print everything. It will give you a complete detail. Starts at 0, goes all the way till 5, right? In the sense, 5 is not included, so excluding 5. So starting from 0 till 5 means it is 4, 0 to 4, right? You have steps of 1, right? That's the other detail which you can get. Once you have this, you can also find out the info, my data dot, I can say yeah, so that is what is called as info. So it says that it's series info. You're trying to find out the information of a series. You can see every value starting from here. Index 0, 0th position, you have 1. Other values are printed below, right? And you can see that the data type used is floating 64-point representation. So we have created the Pandas series, and so far we also have seen how to look at the details of that, like values, index, info, etc. Right? These are the most common ones which we use. So I'll just touch them only. Okay. Then let's move further. How to access? Can you access them by using the index? So the answer is yes. My data square bracket, right, 2. So you will see that this is 5.99. So you can see that index value equal to, sorry, this one, index value equal to 2, it is 5.99. I am able to see that. Okay, I can also see by slicing my data of 1 till 4, right? So it means it's going to show you 1, 2, 3. 4 is excluded. That's how the pandas, sorry, that's how the Python works, right? Fine. So let me know if you have any doubt with this part, whatever we have discussed so far, starting from creating a series and right looking at the various aspects of the series and accessing the series, right? If you have any doubt, let me know. So it's a simplest version how you can create. Now we'll move to the next step. Can I change the index values, right? Index is by default, it says 0, this is the value, 1, next value, second, next value, third, etc. So is it possible to change? If can I give whatever I want, right? So if answer is yes, we can do that. So let's see how it is. So the idea is that index is not always integer. Index, there is no rule saying that you have to make index as integer. But if you don't say that, okay, this is what I want as index or indices, definitely it is going to put the simplest format, which is integer. So by default, you can see here, I never mentioned what is in this case. You see here in this particular case, that is line number 8. I never mentioned that I want this particular thing as my index. I didn't say that. I just said that create a series of these values. So it automatically created like this. But if at all you want to say that what is the index that you want to have, right? You can specify that, right? You can say these are my desired indices. Okay, so let's see. Let me show you how to provide strings as index, right? Strings as indices, right? So let me create my data2 is equal to td dot series. Normally you create the series, okay? So that means I'll just write 1 1 2 2 3 3 4 4 5 5. That's okay. That's all for me. Comma. Then now I'll tell you what are my indexes. So IND index, right? I can say that again, use another square brackets over here, just to say that these are my indexes. If you say start from 10, 11, 12, 13, 14, 15, etc., it will start according to that. But now I want to show you that how the text can be given. So AA, next number is DD, right? Then I want to give CC, then I want to give DD, okay, then DE. So 11, 12, 13, 14, 15. So 5 indices are required. So A, DB, CC, DD, E. So 5 are enough. All right, I created this. Now let me check. So let me try to print this so that you can see. Right now I specified AA as my index, so you have AA 1 1, AB 2 2, and so on. So it should be very clear that now if I want to access them, I have to use an index. Now you see, if I write my data2 of index number say 0, right? What happens? You can still see that, okay? In the sense 0 indicates 0th position. You can do that. That's still valid, right? Otherwise, if you know the what are the various indices you have used, you can definitely use it, right? My data2 of say CC, right? So that is also possible. So just you can access if you provide say other than the default indices, you have two methods to access them. If you know the location, you can simply enter the location as an index, 0th location, first, second, third, fourth, fifth, etc. If you don't know that, definitely you can access that, right, by using the other technique, right? What is the other technique? Other technique will be specifying the index itself. Okay. Now, I have another question that normally I get. I'll try to ask that question and try to answer that. So it's obvious that now the question could be something like, so does it mean that the indices have to be in a sequence like A, B, C, D, or 1, 2, 3, 4? That's the next question we have, right? So the answer to that is we can assign non-sequential, non-continuous indices or pandas, right? Sorry, in case of panda series. Let me demonstrate that as well, right? So let me try to start with the my data3. What happens? So my data3 is equal to xpd dot series of, let me create 1.11 to 3.56. Okay, this is my data. Then I'll enter index equal to, I'll show you the creating the, I'll show how to create indices that are not continuous. So maybe starting from 2, 5, 800 and 1955, let's say. So 4 numbers are there, 4 values are there. For that you need to give 4 indices. Definitely you can give in any sort. So just see here, right? So this is my data3. See, the indices are completely different. All right. So I think I showed you the index, values, info. There is another method, right? Another thing that is possible. My data dot, there is something called as items. Let me check. Is it supported? Index is there. Yeah, items. Yeah, we have items. Yes, it actually shows you the complete details. That's all. All right. Okay, so this is the very fundamental idea about the Pandas series. Okay, my data is over. Now let me show you something else. So how do I access my data 3? And in data 3, I have 800. Correct? Let me see. Yeah, so you can see that. All right. Now there are multiple ways in which you can create a Pandas series, because Pandas is something like high level version of your Panda, the Python. So whatever we have in Python, because Python supports various types of data, such as lists, tuples, and you also have dictionaries, etc. Right? So those are the various things possible. Now you see, what we can try to do here is we can, if you already have created, let's say, a dictionary, I can try to convert the dictionary into the Pandas series. So right now we are going to see that if you have defined some of the basic data types under Python, how to convert them into the Pandas series. So this is what will be our next topic of discussion, right? So if there is a series, so if we already have a dictionary, right, we can convert the dictionary into the series, all right? Because if you remember a dictionary has a key value. These keys can be made as the indices of my Pandas series, right? So we are trying to do that now. Let's try to create a dictionary, right? I'll call it as, it's a population dictionary. All right, so let me try to write like this. So how do you create a dictionary? You use curly braces, and inside the curly brace, you need to say, this is a key, this is a value, comma, another key, another value, like that. So let's try to write this. Sorry, Bengaluru. Let me try to write the population of Bengaluru over here. 9588910. So key value. So once that pair is over, you can enter, you can go to the next line. Let me write Mangaluru. Say approximately 2083625. Okay, then let me write, okay, Udupi. So population approximately 2994744. Okay, next we'll write, maybe values are different, I'm not worrying about that. Masur. Okay, this is 1177908. Okay, let me write a few more values. Okay, let's see that the population is, okay, so this is 1847023. All right, so let's say that this is the dictionary. This is a dictionary. All right, this is not the Panda series. As you can see, key value. If you something try to write something like that inside the flower brackets, it becomes a dictionary, right? So I'm trying to create that. So this is a dictionary now. This is not a Panda series. Now, how to do that? How to convert this into the series? So I'll call it as my series is equal to, it's the same function. PD dot, right? Just you have to mention, I want to get a Pandas series of what? Just tell that, convert this into a Pandas series. So my series dot, I'll look at the information of that. So you can see that. Otherwise, simply type my series. This is just inspection. You can see now there are no brackets like this. You see here, this was a dictionary, but now I don't see that. Okay, so indicating that Bengaluru is a key, right? In the sense it is an index now, it is not a key. Inside a dictionary, this was a key, right? Now under the series, Panda series, Bengaluru is an index. Value corresponding to that is 9588910, something like that. Okay. This is how you create that. Now, definitely I should be able to access that. So my series. BANG. All right. So that means you are able to see. Also, I can check this, my series of, I'll enter. It should be, since it is a text, it has to be, it's a string, right? It has to be under the either single quote or double quotes as per the rules of Python. Okay. Starting from Mangaluru, you can, I want to find out till, okay, this has to be, okay, let's see whether this works. Yes. So in the same order, you will be able to find that starting from Mangaluru. So Mangaluru till Mysuru, this is what I am asking. So you can see starting from Mangaluru, Udupi, Mysuru, those are being shown over here. Okay, so this is how slicing works, even if your index values are strings. I hope that is fine. Is there any doubt? Please either type your doubt in the chat or you can ask, all right, orally. Let me move further. The general way of creating a Panda series is from a list. So I write pd.series and inside the bracket, if I put a list, it automatically becomes a Panda series. For example, pd dot, already we have seen this, okay, Panda series. Just enter the number 11,44,77. So you see that it is actually getting converted into a series by default. So this is the easiest way, simplest way. If you enter in the form of a list inside the square brackets, it automatically gets converted into a series. That's the first thing. Now, if at all I want to copy the same number for multiple indices, how do you do that? So this is supported. You can do that easily. In the sense, I want zero. I want to put zeros at multiple locations. Whenever I create, I want to initialize with zero. If that is the case, you can do whatever we are trying to do now. So this is pd dot series, saying that I want to create a series. So I know that initially I'm supposed to tell which number you want to put. Say if I tell I want to put zeros everywhere, let me assume that I want to create a series of 5 different values and initialize with all zeros. So 0, comma. Now you tell what are the index. Okay. Index, what are the various indices possible you want, you just tell. Okay. So this is something like 1, comma 44, comma AAA. Now you see the different types in which you can do this. Okay. So there are 4 locations over. Let me create the 5th location as well. Okay, so that is right. This I created a series of 5 different values. The length of the series is 5, and all 5 values are 0. I have given different indices for them. That's going to work. Right? Directly you can enter a dictionary and you can convert. Right? Already we have seen that. That is also possible. Right? Then if you want the specific indices, right? If you want to go with the very specific indices, right? You can select something like this. You can do something like this. Let's just see this. I'll just say that pd dot series. I open this. I'll enter. Okay, let me do something like this. Let me create a dictionary first. So dictionary says 22 is the index, and the value could be, say, AAA, right? So that's the first thing. Then I'll enter my next index as a 33, and let me enter, right, X something. All right. Then let me go with another value, 44 index, right? Enter, right? Say D, right? That is done. Now I will, out of whatever we have defined so far, I don't want all of them to be present in my series. Like 2, 2, 3, 3, 2, 2, 3, 3, 4, 4. I have actually entered 3 different indices and 3 different values corresponding to those indices which I have defined. Okay, so now my idea is that I don't want to use all of them into the series, because this is what I have defined as a pandas, as a dictionary. But out of all of these entries, I want to put equal to, index equal to only 2, 2, 3. This is another very important question. So you may have a series containing many things, but out of them, I want to put only few things into my pandas series. How to do that? Inside the index, you create, right, something like a list, and you just mention what you exactly want to be present in the this thing, right, in the series. Now you see only 2, 2, 3, 3 are there. The 4, 4, which is not present inside my index, right? The list containing the indices, it's not going to be present in the pandas series. Okay, so do you have any doubt with any of the topics which we are discussing right now? So we try to basically look at what is called as the series. Okay. Fine. So let's move ahead then. Then I'll move to the second data type, that is called as a data frame. Right. So the data frame, as we have understood so far, it's actually, you can consider the data frame as a specialized NumPy array. One thing you can think like that, or you can also think like that, a specialized dictionary of a Python. So Python dictionary, just now you saw, right? We can try to specialize that, do some modifications, make it very special. Okay, so if at all I want to consider the basics of a data frame, we will have to think that there is a two-dimensional array, because it's a table ultimately. So in technical words, you can say that it's a two-dimensional array. So many rows and so many columns. This is what is the fundamental structure. But the speciality is that you have flexible row indices. A row can be addressed by various indices, as just now we saw. So just now what we saw was we have various indices present and one column was there, right? Now we try to add many columns to that so that it becomes a data frame, right? Very simple. So you have to have indices for rows, and columns have different names, correct? So you can refer them, and generally if you can think like a data frame is a sequence of series. So many series are clubbed together. I have one series, next series, third series, fourth, fifth, and so on. So indices still remain same, X names of your rows still remain same, right? Keeping that same, I keep on changing the I keep on adding various columns to that particular series. It becomes multiple series coming into picture. You are going to call it as the series objects clubbed together. You are going to call it as the data frame. Right? Let's try to look at this. I already have, I think I have a dictionary. Okay, let me do something like this. I think I already have a one series, so that is my series. All right, so let me do something. Let me create another, it's called as a dist for a district, pd dot, or let me do a modification. So let me write the area first, okay? Right, area is equal to, once again, let me create a dictionary, okay? So once again, let me write the same. And I'm going to write the area 539. It's actually in the square kilometers, right? Then okay, then let me write what was DHAR DHARAWADA. Okay. All right. So this is dictionary or area. Now let me convert this. So area series, SERIES, area series is equal to, first let me convert. So PD dot series of the dictionary. The dictionary name is area series, right? Oh, sorry, area is a dictionary. So area. So convert these areas into this. So I have its area series. So you can see that area series looks like this. Already we have another series available that is called as a my series. Okay, so let me change that, my series. Let me try to convert now. Okay, population series equal to, I'll convert the my series into population series. Okay, so that I can understand that what I'm trying to do. So now let's try to create our first data frame. Data frame should have various integers and columns differed by columns indexed by their names, right? I should be able to see the names on the top. So this is how you create. So let me create, let me give the name of the data frame as a district, right? Various districts are what I'm trying to talk about. So PD dot data frame. See, the keyword used is data frame. Open a bracket. Now you have to tell what is the name that you want to give to a particular column. For example, right, this is population. So this is something like, it's a key, and now you have to give the name of that series which you want to put there. So that is, it's a population series, because just now you saw that already we had a my series. So that my series is here, right? So my series, in the sense, it's actually the populations of each of the cities, right? Each of the districts, I try to put that. So this is my first column. So the second column which I want to enter is by the name area. Now it is not a dictionary, okay? Because you can see that I'm saying that I created data frame, not a dictionary. Area, and I'll just write, this is area series. You can see that already we have created an area series over here, right? So I just have to write, I think, area series. Area series. All right, so let's, okay, what was my mistake? Population PD data frame. Yeah, I understand. Right. So there has to be a flower bracket opening and a flower bracket closing up over here. This is required. Okay. Now you see it creates. Go to the district and print. So you see, right, whatever we have created now is called as a data frame. The data frame has the fundamental, see, these are the fundamental characteristics. I can see that these are the names of each of the row we call it as indices. So indices are, earlier I just had this part, right? So I had only this part, this was a series. Now I have multiple series coming up. First series represents the population, second series actually consists of the area. All right. So all together you constructed what is called as a data frame, which is consisting of multiple series and a set of indices. So indices remain column for a row. For each row, there is a unique index. That's the first thing. And each of the column, whatever you see here, has a particular name of the column that is written at the top. So this is this kind of representation where you are using multiple series all together to form something like a table. We will be calling that as a data frame. Okay. So just see that, right? And let me know if you have any doubt with this. Now, how do I access this? What are the various details that I can try to get from this? So the answer is, let me try to look at this. First is that username, that's the district dot index. You can see what are the various indices possible. You can try to find it in the same way like we did for a Pandas series. All right, then the district dot columns, in the sense I will be able to see the various names of the columns, population and area. So first thing is identifying the indices by using dot index. Second thing is to find out the column names by using dot columns, right? So if you want to look at a particular column now, how do I access a column by column? If you want to look at only one column, right? How to do that? So this is how you do that. So this, the district dot, okay, I'll go to the dot notation later. Simply, right, give the name of that particular column A. So only that particular column will be displayed because that column is a series now. How you were looking at the various series objects, like that, you will be able to visualize that particular column as an object, right? So that indicates I can also enter the district of population. All right. Now, let's try to create the Pandas data frame by using, say, list of dictionaries, right? I try to create a list which consists of many dictionaries. I can try to create a data frame from that, right? So if you are familiar with the dictionaries and having many dictionaries inside a list, this is what we can do, right? So let me try to write something like this. My data is equal to, let me try to create a dictionary now. So this is something like AAA. I'll just write I. I'll tell what is I later. Okay. Comma. I'll write the next thing, that is BVB. It's 2 times 2 into let me put an equation here. 2 into I divided by say 3. Okay, so that's my second entries in this, and the third one is say CCC, third key, and the value becoming equal to 2 raised to the power I, right? So this is what I want, and I have to, this is not complete. I have to tell what is I, right? So for I in range 1 to 11. Okay, let me see my data. Now let me visualize that. So you see, we have created various dictionaries now, right? So many, how many dictionaries we created? 1 to 10, 1 to 11. So 1 to 10 is included in that. So that's what we can see. Now I can simply write td dot data frame of my data. So simply you can see that whatever you had as a list of dictionaries. So there is a list here because you are starting with the square bracket and ending with a square bracket. Inside that I have many dictionaries. So this is dictionary 1, comma, dictionary number 2, comma, dictionary 3, 4, 5, 6, 7, 8, 9, 10. All right. So again, we can do something like this. This is pretty much straightforward. Okay, now the next thing you can see here is that we'll try to do something called as a dictionary. We'll try to create a dictionary. We can see that if you miss some of the say keys, right? If you mix the if you miss the keys in the dictionaries that you create and you use those dictionaries to create the Pandas data frame, what happens? Let's see. All right, so let's try to do that in the next thing. All right, this is what I want to do. td dot data frame. I want to create something like this. All right, I'll create a list, and inside the list I will go for a dictionary. Let me say a as my key, and the value is 100, and I have another column called say bbb, sorry, another key, and I want to enter 200 over there. Let me go for a third one. So that is say CCC and 300. All right. So this is my first dictionary. Then I want to go to a second dictionary here. You see that I'll miss some of the what do you call it? Some of the keys. Let me write the first one as it is. So there is a key called A, and let me enter a value for like 500. Then another one, say BBB, or let me miss a BBB here. I'll directly write CCC. Okay, BBB is missed here. In this case, I'm trying to write say 600. Then I miss a B, but I'll add a new thing here. Okay, so that is DDD is a key, and I'll write say 7. See the difference. See what happens now. So basically, if you look at a set of keys that we have chosen all over here, AA is there, BBB, CCC, and DB. But in my first row, right, this is considered as a first row. DDD is missing. So what happened? It gave a value. Since I didn't mention what are the index, what are the various indices required, it takes 0 by default. Initially, we saw that. So it makes sure that gets the first row gets a index value equal to 0. And since along that there is no DDD, you can see here it has only A, B, C, right? So only A, B, 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 C, C, C are there. For DDD, it puts not a number. There is nothing. Okay. Similarly, the second row index is 1, and you can see, right? AA is there, but no BBB, but CCC and DDD are there. So those value will be put up over there, and you can see, right? The BBB, wherever you had it, actually puts a specific value like this. Okay. That's very straightforward, easy to create. So far we were looking at the various options that you had to create the data frames, right? So the other one we have already seen. Let me just make you to remember pd dot the data frame. I can actually create this from the dictionaries itself, right? So if you remember area, I can try to sorry, area, right? I think I had an area series already created, right? That's the first one. Then I can also write population. You simply have to write what is the population dictionary. Okay, I think population series. So directly put that, it actually makes this and it prints like this. All right. So various fundamental some fundamental data types of Python can be used to create the series objects as well as the data frame objects in the pandas. Okay, everywhere you see we are using the PD dot. So that is very important because you have to have the pandas available with you and pandas being imported to your system. Only under that case you can use all these features. All right. So I hope that part is a straight thing for you. Now let's go ahead. Let's see from a two-dimensional NumPy array, because two-dimension means I will definitely have so many rows and so many columns. If at all I have something like that, how do I convert that into a pandas data frame? This is the first thing. Okay, now we are going to see this is the next level. So let's try to do this. PD dot the data frame. Let me open. So I'm using NumPy here. So np dot. Let me create random numbers over here. Random dot rand. I will say that I want create me 4 rows, 3 columns of random numbers. So it's not going to be integers. It's a RAND function which creates random values from 0 to 1. All right. So 4 rows, 3 columns. This is what I have asked. This is my data. Now you see, you have to tell that what are your row values and what are your column names. In the sense, index I need to tell, right? So let me write index equal to. So specify what you want as index. Index could be like I'll say A, A, B, C, E, because there are 4 rows that have been created over here. That those are my indices. Then I have to say what are your columns. Columns again you will put say you have to enter the names, right? So there are 3 columns. Let me enter something like length, breadth, BRE for breadth, let me write HET for height. All right. Okay. Let's see. Randomly, we created some numbers. We gave some names to each of the rows, indices of rows, and column names as required. All right. So this is a very straightforward method to create the pandas data frames. Okay. I hope it is fine. Any doubt you have so far, please let me know if you have any doubt. All right, so let's go further. Now we'll look at the various techniques of performing indexing and the selection, right? So normally how to access and modify the values present in a Pandas series or Pandas data frame is what we are going to call as indexing as well as the selection. Indexing in the sense, I'll just say that, okay, this is how you try to locate a particular value, and selection in the sense from the whole data, I'll pick up some of the data points, right? So first, let us see, right, how do we perform the indexing and selection from the series. So series is just one column. Later on, once you are comfortable with that, we can extend that further and we can do the same thing for a complete Pandas data frame. Okay, so that's my whole idea here. Let's try to do something like this. Let me create, right? So my data is equal to pd dot series. Enter the values. All right, so these are the values, comma. I'll write index equal to, again, I am supposed to write the indices now, a, comma, okay, let me look at my data first. This is what I have entered just now. All right, so first thing is that you can access this directly by using the index. Already we have seen that, but since our discussion topic is indexing, I'll do that again, right? So that is my data, I'll write, see. So we can see it's a 777 that comes up. So this is the first thing, first way of indexing, right? Also, you can do something like an dictionary-like expressions to examine keys, indices, values. So those are possible. First is this, something like I can ask a question like this, BBB in my data. In the sense, I'm asking that whether this BBB is there in this, it says true. Let me check this. AA in my data, it says false. So you see, you can actually do it checking like this. Other than this, I also have an option like my data dot, I think keys as a keyword. Just see that it says everything, right? It displays everything. You can select whatever you want from that. Also, I can do list of my data dot items. I'm asking the machine that give me a list of everything that is present over there. So you see, key value, key value, key value. Everything will be shown in the form of a tuple. Okay, it's a list of tuples. That's what we get as an answer over here. Right? Then this is how you index. If you want to select something and you want to modify something, or you want to add a new value to this series, this is how you do. So I have AAA, BBB, CCC, DBD as the keys. Now I want to add something more to this. This is how you do my data. This I have to enter a new key here, that is EEE, because A, B, C, D are already there. I'm going to put EEE. Right, so after that I'll say equal to 1 2 3 4. Okay, now you check my data, right? If I go back and show you here, this was having only 4 rows. Now you can see we have 5 rows. All right, so just tell me if you have any doubt. So the next part is just to look at, okay, how can I consider the this particular series as a 1D array, right? Because 1D arrays are very easy to handle. We already have done that in the fundamentals of Python class, right? Basic Python class, you saw that, okay, how to create a list and how to handle that. So very similar to that, I can do something here, like my data. I want to say start from BBB and go all the way till DDB. So actually, you see, you can do the slicing by using the explicit index values. In the sense, you know what are the indices you are trying to access. Okay, but if you don't know this, I can do the implicit indexing. I don't know the index values, but in index, so whether it is a text, whether it is what is the text given for each of the index, I don't know. But I know the positions. I want to start from 0, 1, 2, 3, etc. If you want to do that, you can still do that, right? My data of, I'll say start from 1, go all the way till 4. 1, 2, 3, 4, out of which the fourth one is not there. You're going to see 1, 2, 3. So three things will be visible now. So, okay, so this is the other option. But if you want to select only two of them at random, not in an order, so I can also try to write like this: my data of, I'll just say show me AAA, also show me E. What happened? E is not there. Let me just check. I think I made a mistake somewhere. Oh, it's not just this bracket, so typing error. There has to be two. You see? Okay, so that's all. So remember, you should use the first bracket is for indexing, and what are the indices you want to access? You need to write another list inside that. That was my mistake. Okay, this is called as a fancy indexing. So I use a fancy technique to use an index. Okay, that's fine. So far, so good. Let's go ahead. Let's do what is called as, let's use some of the indexers, right? So indexers are there. In a sense, in case of pandas, we have some special indexer attributes. You can specifically or explicitly expose what are the indexing schemes that are present by using what is called as a indexer. So I'm trying to visualize the data based on an indexer. Indexer actually is a way of providing the indices for them. So the first one is called as a LOC, right? Location. I can use also index location, ILOC, and another called as IX, right? Three things are there. Let's look at them one by one. Okay, so what we are looking now is called as an indexer. Okay, so let's start with the first indexer, that is the thing. So first, let me visualize my data once. Okay, so this is the my data, and my data dot ILOC, I location, indicating that I'm telling you which index I want to see. So now this is going to work whenever you don't know what is the type of whether it is a text given as index, whether it is a number given as index. I have no idea anything about that, right? So what I can do, I can simply write ILOC of 1. So it's going to show you what is the first position. In a sense, this is the 0th position. So BBB is the first position. So it actually displays that. Okay, I can also do the same thing like like I did earlier. I can specify show me 2 to 5. So 2, 3, 4 will be shown. Okay. Then for a data frame, if you want to go ahead and do the same thing for a data frame. So this is the fundamental technique that we are going to use. All right. So let's try to do that now. That is, I think I already have a area series with me. Let me check that. Yes, I have an area series, right? And also I think I have already we have created, so I'm using that. Okay, population series. Yeah. Okay. So we have it. Also we have created a dictionary, or not a dictionary. The data frame is already created by the name the district. Just see here. Yeah. So we have this. Right. Now, how to access each column, you already know. We have discussed that. You can use the same thing. District of, I'll say I want to visualize, this is the column name. You enter, only that column gets printed. Similarly, if you write district, right, square bracket, single quote or double quote, you write population, that first column of my data frame will be printed out. Okay, so that's fine. That's what we already know. So there is a dot notation to access this. So simply remember this. This is the easiest one. AREA. Simply write like this. Still you get that. So you don't have to write a bracket, single colon, etc. Not required. So district dot area, district dot. I'll write. I think population. All right. So very easy, very simple. Now I'll tell you how do I add a new column based on existing column. So this is the technique. District of, I want to add a new column. So the new column should have some name, right? So let me call it as density. Okay, this is equal to, in the sense, in the data frame district, add something called as a density. District of that density means it's a new column. If it is already there, it means you are accessing already existing one. If it is not there, you can see that you are creating a new one. So just see here, only two columns do exist. This is a district data frame in which I have only population, first column, area, second column. Now I'm saying that make a new column called density. How it identifies that I have to make a new column, because this column does not exist over there. In the district, you don't have any density column for that. So that is equal to, you can use any formula that already exists. So how do you calculate a density? Population divided by area. So in the district, go to the population column and divide divide the each of the values by district of area. So I don't see anything because I'm not asking something to print. Now I'll ask for district. You see, density has been created. Okay, very easy, very simple. Just have to apply the logic, and I have to stick to the rules of pandas. As far as this is happening, everything becomes very easy for you. Right now, let me check the values. Right, I'll show you something more. That is district dot values. So if you see, previously we had used the values for a series. So all the values of a series was being displayed there. Since it is a series, it was a one-dimensional visualization, right? But now when I call district dot values, see the district, it actually is a 2D, right? Actually, there are so many rows. 1, 2, 3, 4, 5 rows, 3 columns. Okay, so because of that, my visualization, sorry, I wrote a district dot values is what I want, right? Okay, district is shown here. Let me print district dot values. You see, right? This is what is being displayed. So you see, this first row is here, right? 9588 into E06, in the sense 10 to the power 6. So that's what is the population of Bengaluru. Then area of Bengaluru is 539. So this is 5.39 E02, 10 to the power 2. So that makes it 539. Then similarly, you are writing the density. So row wise, I am able to see. So each row becomes a right one-dimensional matrix, or a row matrix in case of the in case of this array. right? Again, I can access each one, right? Something like district dot values. I can say that I just want to see the first one, right? So it actually displays if you have 1, 2, 3, 4, 5, the second one, because index 1 means the second item. I can also say the district dot values of 2 to 4. Okay, 2 and 3 will be displayed, the fourth one will not come. Okay, very simple, very straightforward. Now you see the slicing that is coming into picture, right? I'll use iLock to slice, right? So before that, let me show you the district once again. Right, this is what. Now you see, I just want to see 1, 2, 3. Okay, only the 3 rows, first 3 rows of this particular district. District dot iLock index is what I'm talking about. Okay, iLock. Okay, you can send the iLock in with the square bracket itself. I just have to say all. Do you want to see all the columns? No, I want to see up to 0, 1, and 2. So let me write 3 there. Okay, let me see. I'm not specifying the columns here. Okay, so 0, 1, 2, if you want to see, write it like this. Okay, then I want to see first 3 rows, but only 2 columns, not all of them. So how do I write that? Once again, district of let me see, I want to see first 2 rows and first 2 columns only, not 3. Okay, so how do I write that? First 2 columns in the sense, all the rows until the second one, comma, all the columns until the second one. Let me see what happens. Zero, 1, 2. Oh, my mistake. Sorry. District dot iLock, right? My mistake. I cannot leave that. Yes. Right. So directly district of is not possible. You have to use a iLock because index wise we are trying to identify. So iLock is necessary. Okay. Is there any doubt with this? I'll show you another way of indexing. This is how you can do the district dot. Now you see I'm using LOC location, right? In the sense, I have to specify the exact names, which name you want, in the sense, which name you want to use as index. For example, I'll simply write something like this, okay? LOC of, I'll say everything till, now you see I cannot write 2, 3, 1, 2, 3 like that because you know the location of that. Location in the sense, in this case, it is the index. So I'll write what we have. Okay, MYSURU. Let's see what happens. Starting from everything, including the Mysuru. So that's being displayed. But now I can also specify till which column you want to see, right? So I can try to do that here. District dot LOC of I'll write everything till Mysuru, comma, all right, comma, every column until area, right? So you see, you are actually slicing this in a different way. Every rows, including Mysuru, right? Starting from beginning, every column, including area, that till that. So this is what we are trying to write. Right. All right. Do you have any doubt so far? Right. Everything is should be clear. That's what I expect. Let me know if you have any doubt. The next option is that under the data frame, So far we have seen that we had a particular data frame called the district. Yes. Various types of indexing as well as accessing the various data from the district data frame is what we have seen so far. Now, what if I want to convert the rows into columns and the column into row? Is it possible? Let's see. Dot T. So the same thing we had used in the NumPy to take a transpose of a NumPy array. So same thing, let's try this here. You can see that. So in line number 84, the result shows that city names are along the as a column, and every row is a city name, right? And every column actually represents the various parameters such as population, area, density. If you take a transpose like this, we can see that the parameters coming as along the x-axis and the city names are coming along the y-axis. So that's how we try to visualize this. Now we can actually use the LOC as a indexer, and we can try to combine, say we can do something like a masking, filtering, as well as a fancy indexing. Both of them we can club together. I'll show you how it is. So let me say I want to look at the population and the density of those cities where the density is greater than 15, I can say 15,000, right? So you can see the density values are something like this is 17,000, 8,500, 10,000, 8,700, and something around 3,000, I guess. Okay, so sorry, 38 here, my mistake. So wherever we have more than, I know from this particular data frame, I know the answers. One is Bengaluru, one is Udupi, where the density is more. But without knowing that, what is the instruction or what is the command that I'm going to write so that I can check, right? What are the various cities where the density is more than 15,000? And let me first try to do that. Okay, so that means district dot LOC, and in that I want to check district dot the density. I think density, what was the name? Okay, it was capital, sorry, my mistake. That's why it's not suggesting. Dot density, I'll try to write is greater than, let me write 10,000. So see, it actually gives all the columns, but densities are selected according to the given condition. I just mentioned that I want only those to be displayed where I see that the density value greater than something. So whichever rows have lesser than the specified value, they are being omitted in the display. So I can see that the Dharwada and the Mysuru have been right displays. They are not there. All right. So this is one way. And another way I'll tell you, right? I can actually, if you want to choose specific columns under certain condition, show me only some columns. This is what I mean. The district dot LOC locations. Show me only those locations, in the sense, right? Whichever will satisfy that, it will be shown, right? District dot LOC. I'll say district dot let me say area greater than 200. Let's say district dot, I think area is a capital, area greater than 200, and I want to see, so I have to put a comma here. Now this is corresponding to the rows. I have to tell what I want along the columns. Choose the ones which you want, right? Such as density should be greater than 200, and show me the population and also show me the density. Okay, right? So these are the three different cities having a area greater than how much? 200. You can see here, right? So Bengaluru, Dharwada, Mangaluru. So those are the three cities having area greater than 200. So that's why only those are the rows which are being shown here. And under that condition, I am saying that show me only population and the density. Right? So because of which, right, this is the resultant table. Okay, this is the resultant data that we are going to see. Okay, and let us say I want to modify something. Let me show you the district again, once again. Let me say I want to modify this number. Let me see the density, whichever is there, right? I want to modify this. How do you show that? This is a row number 0, column number 2. I can actually specify by using the same this thing. District dot, it has to be ILOC, okay? Because I'm locating that by using the indexing. So indexing location. This is 0th row, second column. Modify that to be right 18,000. Okay, now you see the district. I can see the change happening. So this was the value. Now that actually got converted into whatever you specify. Okay, all right. Now, okay, there's a time for quiz. I'll ask you a question. Type your answers in the chat box. All right. So the question is that I want you to give me the command by using which I should be able to visualize only the two rows corresponding to Mangaluru and Mysore. Only two rows I have to see, right? So this is a district data frame. Give me the command so that I can see when I run that, I should be able to see only these two rows, all the three columns corresponding to that. Okay, 1 minute of time. Please type your answer within that time. Okay, so we have two answers. Only those who give answers will be evaluated ultimately, okay, at the end, right? So that's why quizzes are pretty much important, just to understand who has understood how much. Anyway, so it's left to you to answer. Doesn't matter, even if you don't answer, it will ultimately affect you in some way at a later stage. Fine. So one of the answer is, let me type. It says district 2 to 4. Okay. So, right? Fine. That's going to work. Let's try another answer given here. That is district. It's a ILOC. And you say you want to look at 2 to 4. And right. Okay. Maybe here it says that I want to look at these two columns, right? You have selected only two columns, but in such case, anyway, I wanted to see all the three columns of the two rows. Okay, so because of that, there'll be a different answer like this. I think only 2:4 is enough. Okay, I think Gauri, you can verify that as well. All right, then whoever has given the 2:4, I think that should work, right? Even if we do like this, we expect this. Okay, so that's fine. Then, okay, we have another answer. I'll just try to type that over here. Just check whether this works. Okay, so I need to make a modification. You say this is to be like this. Okay, everything till Mysuru is what you say, but you cannot give the same thing again, right? In the sense, so I think, yeah, ZR. So please verify. Once I say these are my rows, everything corresponding to row should come here. So next, whatever you enter should be corresponding to the columns. Okay, so I cannot enter the row names once again, right? So please consider that. So I can write Mangaluru to just check. Oh, this is still district, right? Yeah, you cannot use iLock, right? This is the reason. I think I have shown you something earlier. This has to be LOC because you are using the index over there. So iLock is not possible. In such case, you are supposed to use LOC. Okay, just modify. Okay, right? If you want to use the names specifically to access them, you are supposed to use LOC. If you are not sure of the names, but you know what are the positions, you can go with the ILOC, right? So those are the fundamental differences between LOC and ILOC. Is it okay? Now, I will modify the question. I'll print this. I want a command which actually prints out the area and population, of those cities whose population is more than, how much is this? 20 lakhs. Okay. I'll repeat the question, right? I'll write a question here so that, right, you can try to answer that, right? Print the area and population, okay, area and density of the cities having the population greater than or equal to 20 lakhs. Okay, so this is my question. Yes, please go ahead and type your answers. Okay, so we have few answers in my chat. Let's just verify them once. So let me go back to this scenario wherein we actually had checked that one condition, that is district dot LOC, those locations, go to those locations where area is greater than 200. That was my fundamental condition. Condition that I want to look at only those cities whose area is greater than 200, right? And whichever cities will satisfy those conditions, show me the population and density. Okay, so this is the answer for that question. Okay, just look at this because I think there is some confusion whether to use LOC, whether to use ILOC, etc. I can see right from the answers that I have right now. Okay, so look at this and try to answer my question. Right, so this is how your answer should be formatted, but maybe the fields will change. Maybe you want to change something here. Maybe you want to change them also. Okay, so this is how I'm expecting a command, but modify this command according to this question. Print the area and density according to the population. Okay, so if you want to modify the answers you have given, whoever has given the answer, please try to modify according to this question. Right, so look at this. This is my question, and the format in which you are supposed to answer is like this. All right. So let's try to write that. I want to go with district of, I want to go with ILOC, right? So district dot, sorry, LOC, where the, sorry, the district dot, according to the population, it should change, right? District dot population is greater than this. This is my condition, comma. I need only few things. What are they? One is area, and one more is density. Okay. Perfect. All right. Right. We have few answers with us now. That's fine. Now, let us try to apply some of the standard existing functions to the maybe the Pandas series, or you can also apply the to the data frame, right? So that's what we are going to see next, right? Let's try to create a series now. First, I'll discuss how to apply the functions to series, and then we'll go for the data frame. All right. So this is my series is equal to PD dot series np dot random dot rand, oh, there should not be a space, rand int of 1, 11, say 5. Let me create this. Let's look at my series. So I'm totally creating 5 different numbers. Okay. And 1 to 11 is my series. Between 1 and 11, excluding 11. So this is 1 to 10. Right. So that's how the numbers have been created. Now I'll try to convert them into, let me also try to create a data frame. All right. My df is equal to my data frame is equal to pd dot the data frame of np dot random dot rand int of, I have to set the size 1, 101, minimum 1, maximum 101. Let me say I want 4 rows and 5 columns. Okay, so this is the first thing. Then the columns, I specify the columns in this way, say AA, comma B, sorry, AA, comma, a mistake, BB, sorry, under the single quotes, BB. How many columns? 5 columns, right? Okay. Then CC, comma, DD, comma. All right, so we have 5 columns. So this means I'm trying to create a data frame now. Okay, let me print my DF. So 4 rows, 5 different columns are being shown. So first, let me try to apply some direct function to this, right? That is a my series. So that means look at the various functions that we had used. Functions in the sense you can try to recall what is called as a unary functions, right? Which means simply you can call the functions to a complete row, complete column, right, or something like that. This is what I mean. np.exp, right? np.exp of, call that series, my series. What's the name? Yeah, my series. See, this is the answer. So whatever values you had here, right, you are trying to raise it to the e to the power. So e to the power, every number is what you are going to see here. Similarly, I can try to apply, right, a function to every element that is present in the data frame. So that this is how you can do that. np dot, I'll apply a cosine value, np dot cos of, so let me try to write something. It's 2 into, this is pi. If you want to pi, it is present under the numpy, np dot pi, pi, into, right, my, what was the name? Sorry, not my series. I think it's name of the data frame, my dear. Okay, my dear. I'll try to divide that by 100 or 1. Okay, I wrote 11. That's fine. See, this is the answer. I applied a cosine function. Every element in the data frame is multiplied by 2 pi, right, divided by 11. So as a result, you are able to see something like this. Is it okay? Fine. So let's move ahead. Let's try to create something like this. Let me try to create two different series. All right. So let me say A is equal to PD dot series of, okay, 223366 comma index equal to, let me try to write 0 comma 1 comma 2. So this is my first series. Let me try to inspect that. So this is what is my first this thing. Okay, then I have B. B is equal to PD dot series. Let me try to write a series again here. So that is 11 comma 44 comma 88. But now you see what I do. I'll try to give different index. Okay, index is equal to, let me write 1 comma 2 comma 3. So there is no index 0 over here. So that means when I inspect this, I'll be able to see something like this. Okay, now you see, whenever you try to add these two now, such as A plus B, I know that the numbers can be added. 22 can be added to 11, right? 33 can be added to 44, 66 can be added to 88. That's not an issue here. Issue is which index. What happens here? The pandas looks for the index. Pandas matches for the index, in the sense 0 is there, index 0 is there with the value 22 in that. But in the second data frame or second series, I don't have a 0, which means to 0 it is not going to add anything. Result is not defined. But 1 has a value 33. Here I have 1 with 11. So 33 plus 11, you get an answer. So 2 has 66. Here 2 has 44. So 66 plus 44, you get an answer. But you see, there is no 3 in the first data frame. That is A, first series. Sorry. So in the first series, I don't see 3. So to this 88, you are not able to do a addition, right? Because of which you get not a number as an answer. Right, so this is what is going to happen, right? This is very important. Whenever there is no matching, right, happening over there, then we have such situation coming into picture. But this can happen when you have a very huge data set wherein you have no idea that there are so many not a numbers present in my answer. So to avoid that, what you can do, this is the solution. Okay, this is the practical solution which you are going to apply, right, whenever you are writing the code. So you will perform, you will use a function called add. Okay, a dot add, right? So you will say that I want to add B to this. This is the same function we did, but you will add something to this. You will simply say that fill, you will say that fill, there is what is called as a fill I think fill val, it's not suggesting. Let me write it and check. Fill value equal to 0. In the sense, if you don't have something, add 0 to that. Now you see, wherever the index is not matching or some index which is missing, it assumes a 0 over there, and now it actually provides you the answer. So very important, right? That's why I'm stressing this. Okay. Then let's do anything. Let's do a different approach here. Now, what if column wise you have something missing? All right. So this is called as index aligning the index values. Right. Let's see how to do that. Let me create a now. So a is equal to pd dot. This is with respect to the data frame. So far, I was looking at only series. So in a series, if you miss something, you can simply say a dot add if you are adding, right? Similarly, multiply, you have divide, you have, etc. Various things are there that you will get a complete details in the notes that you get. Okay, but as of now, you understand that along series, this is the method, right? You simply say fill value equal to 0. But when it goes to the data frame, you may see the what you call missing values in any rows, any columns, right? So my approach is very similar to the one which I have used so far, but there is a small difference. Okay, so let's look at that now. So pd dot data frame, let me create a data frame, np dot random dot rand int. Let me say I have to use the values between 1 and 50. So I'll write 51, and I want the size to be 3, 3. Okay. Right. Then I'll say columns equal to, you see, I'm trying to I'm trying to take something from the basics of Python. So I want it to create a list. Create a list from DCE. Okay, so DCE, this is what I say, right? In this particular order, make a list of this and create me, use the list, and every element of a list should be created over here, right? As a column. So what happens? This is what is going to happen. Let me try to print A. So D is separated as a single character, it is used as a column. C is the second one, E is the third one. So if you don't have anything specific in mind that, okay, these are the names of the columns, simply you can say that make a list of so and so, and that will be used, right? Another very easy and very important concept, right? So just remember, okay, columns can be created in this fashion. Okay, now what I try to do here, I'll also create a different what you call data frame. Let me call it as a B. Okay, B is equal to pd dot data frame. I will create np dot random dot random integers. And now I'll create 1, 101, I'll say I'll keep the number of rows same, but I'll make sure that the columns are less now. Let me say only 2. And I'll say index is equal to a list of, so previously I had DCE. Okay, I'll simply write DCE. So I'll write EC. That's it. Okay. And let me try to print what happened. Not index, sorry. Column, right? My mistake. Sorry. Oh, still the column. Columns. Sorry. Again, my mistake. So just try to print a B here. Okay. Now you see, integers are same. So 0, 1, 2, 0, 1, 2. But the columns are in the first case A, we have 3 columns, D, C, E, and in the second case, you have EC, that's all. D is missing. Now you see, if I try to add A plus B, wherever I have a missing column, that column should become NaN, because one of them has that, other one does not have that. So this is a problem. All right. So what I do, I'll try to perform what is called as I'll try to calculate the mean of a particular this thing, right? Particular column, and that mean value I'll use it, right? For whenever I do the addition, I'll use that. Okay. So for example, right, for A, I'll try to take a column, take a mean, right? So let me try to do that. So the fill value is equal to, this is how you do that, A dot, there is a function called stack dot, I want to say take a mean of that. Now you see, this means it is, what is the fill value? Fill value is the mean value. Okay, mean value of A. Now what I do, I'll do the same thing. A dot add, this is what we did earlier. I want to add A to B, but what is the fill value now? Not fill value, fill underscore fill value is equal to, now I can write the one which I have calculated, fill value. See the result? Right? We got a value for D now. So D is not missing. D has some value coming up. Okay. So very important. What are the other than add? You have sub, you have subtract, multiply, right? Div, divide, floor divide, mod, power, etc. are available. Okay. So details of those functions you get in the material that you get after today's session. Is it okay? Okay. Then we'll go ahead. And this is pretty much important. That is, what do you do with the missing values? So the concept of missing value comes into picture because of some practical issues with the data set that you collect. So let us say our ultimate goal is to solve a problem using machine learning. For that purpose, I start collecting the data, right? For example, I want to predict what is going to happen. Will it rain after 2 days, 3 days, 4 days, 10 days? This is what I want to predict using a machine learning technique. What I do, I collect the rain data using a sensor. Let's assume I'm not going to the internet to collect the data. Let's say I want to have a practical sense, so I build a circuit, maybe using Arduino or Raspberry Pi or whatever, right? I interface various sensors like rain sensors, humidity sensors, and maybe the air quality sensors, etc. Many things you interface. After interfacing that, I collect the data, right? So there are sensors which are actually practically sensing the data, right? And let's say you do this experiment, you keep running that machine for say 10 days. So you have 10 days of data. Maybe you will make a sampling rate of 1 sample per second, right? Every second you get a data from each of those sensors. So if you are using a temperature sensor, in 1 day, how many values you get, right? So 60 per minute. 60 into 60, 3600 per hour into 24. So that is the data set you collect from one sensor in a day. Multiply that by 10. So that is your data set for one sensor. You have 3 sensors, 3 into that size. So it's a big data. All right. Now what happens? Among those different data that you have collected so far, right? You will see that some of the values are missing. Right? This is a practical sense. Why do you miss? Because of the practical issues. Maybe the voltage fluctuations are there in your device because of whenever the input voltage to a particular sensor is right slightly lesser than what is required, it will miss a data. So what happens? Your program tries to catch the incoming value every 1 second. Whenever the sensor is not giving a data, it puts a missing number over. So each of the machine has its own code to indicate that, okay, the data is missing. So you always have a missing data. That is, whenever you collect a data set in practice, practically you collect something using a hardware or something, yes, definitely you face this kind of issues. It's called as a missing data. So now already we understood that we are going to deal with a huge data set, like 10,000 rows. So 10,000 columns, let's say. If such a huge data set you have, there will be n number of missing values. N is very large. So in such cases, what we are going to do, what are the options we have? This is what we are going to study now. So we'll look at that. So let me try to create something like this. Let me create a array. My array is equal to, I can try to create something like using the numpy np dot array. So how do you create a np array? You have to put a list inside this. So 1 1 comma 2 2 comma none comma 44. So we have used this, so you know what will be the answer. If I try to write my array, it actually shows like this. It's an object. So there is what is called as another version, right? Because none is one option. Another option is called as a not a number, right? So it's actually a floating value which can be recognized by all systems. Maybe this none is not recognized by some other systems, right? Which are running on a different platform. They may not understand this. So what we do, we use another data format. So my array2 is equal to, once again, I'm creating the np dot array. All right, I'm going to put a list here. So just see, this is 1 1 comma 2 2 comma. Now instead of none, I'm going to put np dot nan for not a number. Okay, comma 44. Let me try to print this. My array2. So you see, it actually is a not a number, NEM. It's a float, because you see all the numbers we have created, we have used here are integers, right? I know that if there is a float, everything will get converted into float. So because of that, I can understand that since 1 1 2 2 4 4 have been converted into float, so this NAM is a floating representation. Okay, so I was expecting a integer, but that's how it is. Right? So what is a not a number? Not a number is something like if you add, subtract, divide, do something like that, right? Definitely that is, the answer is not a number, something like infinity, right? So just see here. Let me try to do something like, let me do 100 plus np dot nem. So 100 plus infinity is infinity. It's like that. So if you try to do 0 divisible divide by np dot nan is also nan, right? So if you try to find the maximum value from an array which contains nan, this is the answer. So my array, right? My array2 dot sum is not a number, because among those arrays we have, right, not a number present over there, right? At the same time, my array2 dot max, this is to find the maximum of an array. It's not a number, because there is not a number present. Similarly, even if you put a min, it's going to be the not a number. So that's what is a not a number concept, right? So how to avoid this? Because definitely I'm going to have not a numbers whenever I consider a large data set. So how to avoid that? So there is a facility. So you can tell that what you are supposed to do with the NAN, right? So the first option is something like this. np dot, you call it as a NANSUM. Do the NAN sum, in the sense, neglect the NAN and do the sum, okay, of my array 2. See, we have an answer. Okay, 11 plus 22 plus 44. Similarly, you can also apply everything that we have done so far. So that is np dot nan max of my array2, right? So this is a max. Similarly, you can apply for min. So if you call nan max, nan min, nan add, etc., right? So you nan sum, etc., you are still able to find that. Okay, so that's the fundamental difference over here, right? Now, what happens in pandas? This details, whatever you have seen so far is under NumPy. Okay, NumPy handles in this way. Let's go to the pandas version of that. So pd dot, let me try to do with the series. So pd dot series or enter the same thing, 11, comma 22, comma 23, comma NONE, comma 44, comma, I can try to write the np dot nan. All right, now you see the difference. The none which was present there is a nan, is converted into nan. Okay, np dot nan, which is actually a nan, is also remaining same as nan. So this is a fundamental difference between, right, the none and the nan, both getting converted into nan itself when it comes to the pandas. Similarly, in case of the NumPy, they are separate, right? Why they have done like this? Because whether it is none or whether it is nan, there is no value present over there. Consider them as a same entity. Okay, so let me show you something else. If I try to create a data series like this, pd dot series range, I try to create range as 5. Let me see A. Okay, this is what I have. Now let me try to assign some A of 1. Let me try to put this is equal to none. Okay, and let me inspect A, right? So 0 becomes 0.0 because NaN is a floating value. Everything got converted into floating value now. That's how it is. So you can see that I can assign, say, A of some other number. Say 3 is equal to, I can try to assign np dot NaN. This is also possible. So if you require, you can definitely do something like this. All right. So another very important concept. Now let's go to the series, how to detect, right? Because you have a huge data with you. First, you want to know that whether there are nulls, none, etc. Do you have it, right? Do you have it at the first place? I just have to find that out. Okay, so this is the procedure that you're going to follow, right? So that is my data is equal to pd dot, this is a series object. Let's create 11 np dot nan, I'll write a text, say namaste, and I'll write, say, okay, I'll write a none here. Okay, let's see what happens. This is my data. This is my data. Let me check my data once before I proceed further. Yeah, so I have two different things. Okay, one is none and one is this. Now I can actually check something like this. My data dot is null. So is null is a function that is used to detect whether you have a null or not. You see here, this is a null. This is not a number. In the sense, this is nothing. This is also nothing, right? So you can see true comes over there. In index 1, is null is true. In the sense, there is a null. In index 3, there is also a null. Okay, so this is how I try to find out. Now, what if I want to check what are the not null numbers present over there? I can simply do something like this. My data of, in my data, tell me what are the not, I think we have not any, not null. Yeah, you can apply not null. All right. So you see here, it actually displays only the not null, which are other than the none, NaN, none, etc. After removing that, whatever remains over there, it will display that. Okay. So one very important aspect here is being identifying, right? Identifying not a number, identifying null number, identifying, right, NaNs, etc. That's the first thing. And how can you see whatever is not null? We can use a function called not null, and you can visualize that. Okay, so that's the first thing, right? The second thing is that we have a built-in function to drop the null values. I can completely eliminate the null values from the complete data frame or the series. Okay, so removing it will be done by drop NA. If you want to fill something, wherever you find a null value, you can fill something. That's also possible, right? Let's look at that now. So let me look at my data once. Okay, so this is my data. So in my data, let me try to show you something. My data dot drop NA. See, right? It simply dropped, right? It's equivalent to doing this. So instead of doing this, you can do this. Then you can use a built-in function called drop NA. Okay, this is what happened with the what you call as a series. Now I'll show what happens with the data frame. Okay, my df is equal to pd dot data frame. Let me try to create something like 11 comma np dot nan comma 22. This is my say first row. Then I'll go to the second row, 22 comma 33 comma 44. My second row, we go to a third row, and I'll enter np dot man comma 55 comma 88. Let's say this is a data frame, my dear. Okay, so this is what has been created. I did not mention what are my columns, what are my rows, so it actually assigned 0, 1, 2, 0, 1, 2 to that. This is what is a default. Now you see, I'll simply say that my dear, my data frame dot the drop NA. You see, I am retaining only one row because, right, whichever row had a NA value, that row gets completely eliminated. Okay, that is one thing. Now, what if I don't want that to happen? I want the columns. I just want to remove the columns which contain the not a numbers. So in the sense, I want to retain the column number 2, right? In this, right? Is it possible to do that? So the answer is yes. So how to do that? How to define that? You can do something like this. My not my data. Sorry, it's my df in my data frame. Perform the drop NA, open and close bracket. Inside that, you have to say that which one you want to keep, right? Sorry, which one you want to remove, in the sense, which direction, rows or columns. By default, this is a rows, right? This actually is a row wise. When you don't say anything, it will remove the rows containing not a numbers. But you see here, I will specify the axis. In the sense, axis specifies which direction you want to go, so that if you find a not a number, eliminate that column now, right? So you just have to say column or columns. I think columns. Okay, right? You can see second column is retained, other columns have been removed. So if you want to remove row wise, don't specify anything, simply use this. But if you want to say, I want to remove the columns containing not a numbers, you have to do like this. So that's the difference when it comes to the data frame. Series has no such issue. Okay. This is our first objective. The first objective was, if you find a not a numbers, not a NaN values, you can eliminate. So from a series, you can eliminate, from the data frame also you can eliminate, right? So this was the first objective. Now the second thing is that I don't want to remove, because I lose a lot of data if I simply remove. Is there any method to fill the not a numbers by something such as a mean, something like as anything, mean, median, or something like that? Can I fill that? Right? So let's check that. Right? So let's try to do something like this. Let me go to Let me check what I have done with the my series. Do I have a series available? Yeah. So A was a series. Let me check A. What is there in A? Oh, A. Yeah, you can see A is like this. All right. Now, what I'll try to do here is I can simply say that A dot, that is what is called as a fill n, indicating that I want to fill not a numbers by something. So you can simply say that fill it by, say, ABC. Just see, right? Wherever you had a not a number, right? They are filled with a specific one which you see. I say I want to put 55. I want to say that I'll put that as 0. So specify that, that will come over there, right? This is the first thing. All right. Then let me say A now. A is still the same thing. A has not been modified. I just said that, okay, in A, if I fill it with ABC, this is what I get. I have another option called as forward fill. Let me show you that. Okay. So that is A dot fill an A, right? If you simply, you cannot simply say like this. You have to tell something like mention what you want to fill. That's what we have done earlier. And now I'll specify a method. So method is equal to, you call it as FL. So just see what happened. Forward fill in the sense, if you have a value like man, right? Bring your previous value and fill it forward. So previous value will be filled at the position of man. So 0 is being filled here. Similarly, the next nan I find here, before that, whatever you have, that is a 2, will be filled in the position of nan. So this is called as a forward fill. You can do that because in a column, like I'm measuring the temperature. Right now, the temperature is 21.5 degrees, right? The next temperature could be 21.6, but it misplaced. There is no value present. So at least you can copy your previous value and put it over there, right? That actually, I cannot say that doesn't make sense. That makes some sense because temperature is highly correlated data. Temperature cannot vary by a huge factor if you are measuring the temperature every second. Like whatever is the current temperature, maybe slight variation of that temperature may be located in your next second. So because of that, this is pretty much valid. So we use something like this. That's why I'm stressing this. At the same time, let me go back to A. I can also try to fill with the backward fill. That's also possible. All right. So this is capital A dot fill NA. I have to specify method equal to, just specify this is B FIL. B fill in the sense I'm filling the backward. So whatever is next number, you are trying to fill that. So this is my not a number, right? Next number is filled over there. So 2 gets filled over here. So look at the previous answer. Previous answer was 0 was being filled there, right? My previous number is being filled. Now the next number is being filled at the previous position. So similarly, if I have a not a number here with respect to 4, the 4 will be brought back and filled at the position 3. All right. So this is what is the option with respect to not a numbers in case of a series. This is a series. We are discussing about a series. Now let me go back to the, sorry, just give me a second. Sorry about that. Sorry. Fine. So we have, we'll go back to the data frame now. You can see that my DF is a one which actually has 6 different, sorry, 9 different elements, and we have what you call 2 different not a numbers. Okay, so let me bring that over here. My DF. So just see my DF is this. Now let us see how to fill this. How to fill this not a numbers with previous number, next number, etc. So first option is, I'll just say that uh, my DF dot fill NA. I just have to tell which method I want. Method equal to, you can go with the ffill first, ffill, and now you have to say forward fill is okay. Whether you want to do the forward fill row wise or the column wise, right? So you want to go look at my next number from the column and you can fill, or you can look at the next row and you can fill. All right. So in such cases, let me first fill this. Okay. So this is axis equal to 1, right? I want to look what is there, right? 1 means it's a column wise I'm reading. So whatever is the next number in the column, I'm trying to fill that. So what happened here, right? My first not a number is located over here. For that, right? Whatever is the previous value, I can fill it, right? So I'm actually one means zero means, sorry, I think I misplaced when I told earlier. Zero means I'm looking at columns. Zero means I'm looking at rows, right? So in such cases, you can see here, right? Sorry. I have to look at what was my previous number. So previous number is 11, right? I'm saying 1. 1 means I have to look column wise, right? 1 is column wise, 0 is row wise, right? So I'm looking at previous column to next column. So that means, right, 11 is getting filled to the next, not a number over here. So I'm filling the 11 over there, because of which I'm getting this. But to fill this NAM, I don't have anything previous to that, right? So that's why this not a number is kept as it is, right? So you may consider this as a drawback, right? But still, yes, this is how it works. Let me show you another option. My df dot fill NA of the method equal to bfill backward axis equal to 0. Now you see what happens. I'm saying backward fill, right? Axis equal to 0. In a sense, I should look row wise. In this case also, this not a number remains as it is, because I had a not a number here. I am filling with the next number from the row, right? Next row, that is 33 is filled on that. In the sense, along the same column, go to the next row, fill it. But along the same column, I don't have a next row here for this not a number. So this remains as it is. So if you want to fill something, maybe you can change it to ffill and axis 0. See what happens. In such case, the other not a number remains as it is, because before that I don't have any number, right? So maybe you have to apply the fill NA twice. Now, if you once again call with bfill, right, axis equal to 1, the other not a number is also going to be filled, right, by using the next number that is present over there. So have to be careful, right? Even after applying the fill NA, if some of the not a numbers are still going to be present over there, right, then we need to be very careful. Okay, we may have to apply the fill NA once again. Another time you may have to apply that, so that it becomes a very proper, what you call, properly filled data frame. Okay, all right, fine. So I think the basics of pandas we could cover today. There will be another session on pandas, because of in which we will be able to explore further. We'll go to the advanced topics under pandas, right? Because we may not be able to keep only the basics of pandas, and we may not be able to go to the application level problems, which includes solving the machine learning issue, machine learning algorithms, etc. We have to go to the advanced level. All right, so that's the first thing I want to tell. Right, there may be another session. I'll decide. Let me see what will be your problem definitions, right? So in the sense, which machine learning algorithms you are going to solve, I have to decide that now. So first, let me go.